Hi, everybody. Welcome back. So we're going to be continuing talking about the graphs of sine and cosine. Today, adding in the translation. So that's the phase shift and the midline. Now, if you recall from the notes that we've taken earlier, that phase shift is really just a horizontal shift of the graph, and the midline is really corresponds to a vertical shift of the graph, just like our function transformations from earlier in the year. So that phase shift, when I'm subtracting an h value, that would shift me h units to the right. And when I'm adding a k value, that will shift me k units up. So let's dive right in and look at a couple of examples. So we're going to look at 3 examples over the course of this video, being -2 sine of x plus pi over 6, y equals cosine of x minus pi over 4 minus 2, and y equals -3/2 of cosine of quantity x plus 5 pi over 6 plus 1. So to first get a handle on it before we actually dive into an equation, I want to really show what's happening with this first graph. So over here on the calculator, I have the graph of y equals sine x. And in red, I'm just going to plot the graph of -2 sine of x plus second pi divided by 6. So that we can compare these two graphs. Now I'm going to point out a couple of things. So one, I'd expect this graph to be twice as high because it has an amplitude of 2. Secondly, because of that negative in front, I'd expect this to be vertically reflected. So rather than rising to its first key point, it should be falling to its first key point. And additionally, because of this pi over 6, I would expect a shift of this graph of pi over 6 to the left. Okay, so I'm going to click graph and just compare how it looks. So as I said, it's falling to its first value. And if we zoom in a little bit, we could see that, here, I'll make it actually much larger so that we can see it. That midline intercept has been shifted over, and that value corresponds to pi over 6. So this graph has been completely moved to the left a certain amount. So we want to try to describe that in our graph, and that's what we're going to do right now. So let's get right to it. So my first equation is this one. So I'm going to write it out here. So I'm going to have y equals -2 sine of x plus pi over 6. Okay, and I want to make this graph. So just like before, I'm going to do amplitude, frequency, and period, my helper descriptors to help me scale out my graph. Those values I can read off from here. I have an amplitude of 2, that coefficient of the function. It is a positive 2, even though there is a negative here, because the amplitude is a distance measure, so it's always positive. The coefficient of the x term is 1, that corresponds to my frequency. And then the period is always, for sine or cosine, 2 pi over the frequency. So in this case, that's just 2 pi. The values I'm going to add for this graph is a phase shift and a midline description. Okay. The phase shift is the horizontal shift. In this case, I'm shifting it pi over 6. And because I'm adding, and the shifts in the x direction appear in the opposite of what you might expect, this will be pi over 6 to the left. And then I'm not adding anything on to the end, so I haven't done any vertical shift. My midline will be at 0, as it was for all of the graphs we've done so far. Okay, so now I'm going to scale out my axes. I'm going to draw my axes in. Myself lots of space. I'm giving myself lots of space over here because, like we've done before, I'm going to graph 2 cycles or 2 periods of this graph. So I'm giving myself enough space to do that. Additionally, I need to scale out the axes like we've done before. So I have a midline at 0 and an amplitude of 2. So I really just have to go up 1, 2, and down 1, -2. Okay, so it's my vertical scale. Now the horizontal scale is a little bit trickier. What we've done up to now is we've taken that period and we've just gone out and labeled the period and then gone the equivalent distance and then labeled the second period. Where this is tricky now is because we're not starting at 0 and going those period distances. We're actually going to have to shift this all pi over 6 back. So I can't go ahead and label my periods yet. What I need to do is figure out where my graph's going to start. And since I'm going pi over 6 to the left, I'm going to do a little dotted line 1 box over, and I'm going to label that -pi over 6. And that's where my graph is going to start. I then have to go 2 pi past that. So I have to add 2 pi on to figure out where I'm going to end. But these are unlike terms, so to help me make sense of it, I'm going to rewrite 2 pi in terms of sixths. So 2 pi would be 12 pi over 6. That's an equivalent for 2 pi. And I do that because then I can combine these two values a little bit easier. So if I'm starting at negative pi over 6, and I need to go 12 sixths over to get to the end of the period, I'm just going to count out 12 boxes. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So I've gone 12 boxes over. And if I've gone 12 over from negative pi over 6, I should land myself at 11 pi over 6. Okay. Now, if I want 2 periods, I'm going to have to go another 12. So I have to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 pi over 6. Past that, you can't really see my value. Slide it in a bit. Okay. And if I'm going 12 past 11, that should put me at 23 pi over 6 at my ending value. Okay. So if I'm there at 23 pi over 6, I then have to break this up like we've done before into 4 equal parts. So I need to go halfway in between these. I'm going to count off, if there was 12 in between each one, I'm going to count off 1, 2, 3, 4, 5, 6. That should be the middle of my period. And then it should give me 3 and 3. So I have 3, 3, 3, 3, 4 equal parts along that period. And I'm going to do the same thing here. So I'm going to go 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. And that gives me my 4 equal parts in each period. That's where my key points are going to occur. Okay. So I've gotten all my labeling done. I know where my midline is. I know where I'm starting. Now I just need to figure out what this graph looks like. So I'm going to picture the original sine graph. So this is the graph of sine. But here, because I have a negative, I'm going to have to reflect this graph vertically. So what that's going to do to my function is that everything should be opposite. So the graph of negative sine would be the exact same graph, but rather than rising, it should fall. And that's the graph of negative sine. So that's the graph I'm going to use. So my key points are, again, it's zeros, and it's max and it's min. It's turning points. So I'm going to transcribe these points to my key points on this graph. So starting at my start, now my start is not the axis now because I've been shifted over. My start will now be at negative pi over 6. Then at my next key point, I should fall to my minimum. Then back to the middle, up to the max, and then back down to the, oops, I skipped one. Sorry, skipped a value. Here, up to my max, my next key point is here, and then back to my 0. I knew I made a mistake because I should complete this cycle by the time I get to my labeled end of period. So when I got to here and I wasn't there, I knew I had made a mistake. That's how I had to go back and reanalyze. And I had placed a point not on one of my key point markings. Okay, so there is one cycle of this graph. If I want 2 cycles, I'm going to continue this pattern along its second period. So I have my point here, I have my next point, my next point, my next point, and my last point. Okay, and there's my 2 full cycles of my sine graph. Okay, I'm going to hop right into the next example. So I'm going to erase, fill in the next equation. My next example is y equals cosine of x minus pi over 4 minus 2. Okay. Starting off the same way, I'm going to identify all those key pieces of information, the amplitude, frequency, and period, and the phase shift and the midline. My amplitude here, coefficient of cosine, is 1. My frequency here, coefficient of the x term, also 1. Makes my period 2 pi over 1, just 2 pi. The phase shift in this case, I have pi over 4. And because I'm subtracting, this is going to be a shift to the right. And then I'm subtracting 2, so my midline will be 2 units below the axis at negative 2. Those are each of my key pieces of information, my phase shift, my midline from those values. So I'm going to draw a set of axes. Now, because my midline is -2, I'm going to give myself some more negative space. So I'm going to draw my axis, my x-axis, a little higher to give myself more negative space because everything is 2 units below where it would normally land. I'm going to label my x direction first. So I have pi over 4. So I'm going to have to shift over pi over 4. So I'm going to make a little mark. Maybe I'll skip 2 boxes to give myself some space. Here, I'll call that pi over 4. Okay. Now I need to figure out where, if that's the start of my period and I have to go 2 pi over, I need to figure out where this period's going to end. So I'm going to rewrite 2 pi in terms of fourths. And that would be 8 pi over 4. Okay. That means I have to move 8 pi over 4 boxes over. So I'm going to count that out. I'm going to go 1, 2, 3, 4, 5, 6, 7, 8. Okay, so I'm looking at this, I'm now regretting the scale a little bit because it looks like I'm going to take up a lot of space. So I'm actually going to go back and I'm going to change this to just 1 box being pi over 4 because I see I'm not really going to have enough space to get 2 full periods. So I'm going to make 1 box pi over 4. And now I'm going to count out 1, 2, 3, 4, 5, 6, 7, 8. And if I'm going 8 past pi over 4, that would put me at 9 pi over 4. Okay, and if I want 2 periods, I'm going to do another 1, 2, 3, 4, 5, 6, 7, 8 fourths, which will put me at 17 pi over 4, 8 pi over 4 past 9 pi over 4. Okay, so there's my 2 periods. Now I'm going to break it into 4 equal parts. So I'm going to cut it in half, and then each half in half. Cut it in half, and then each half in half. And that gives me the location of the 4 key points along this graph. So I have all of my values marked in here. Next, I have to do the vertical axis. Now, since the amplitude is 1 and the midline is -2, I am actually going to skip every other. So I'm going to say that's -1, say that's -2, say that's -3. And that should be enough, because if the middle of my graph has to be here at -2, I'm only going to deviate 1 above and 1 below because of that amplitude of 1. So I have this all scaled out now. I have my key points labeled. Now I just have to transcribe my understanding of the cosine graph. So cosine should look like this, with a turning point and zeros each a quarter of the way through. So now I have to figure out my starting position. So this intercept of the axis is now, because of the transformations, because I've translated it to the right and down, this part that was normally the origin on the cosine graph actually corresponds to the intersection of these little dotted lines I made, corresponding to those shifts. So the cosine graph starts at its max. So from where the midline is, I'm going to go an amplitude above that, which would put me here. That's that starting point. That next key point should be the interception along the axis, but because I've been shifting it down, that will now be the location of where the midline is. I'm going to go down to the next key point. That should be right here, over and up, and over and up. And that gives me my first cycle of the cosine graph. I then repeat this pattern, so I have my values, this value, and this value, this value, and this value. And I get a second cycle of that cosine graph. So there's my 2 cycles. For the last example, I'm going to put it all together. This is the most complicated example we've covered so far, coming up. Okay. And I'm going to graph y equals -3/2 cosine of x plus 5 pi over 6 plus 1. Okay. So I'm going to go through my characteristics: amplitude, frequency, period, phase shift, and midline. I'm going to identify these 5 things. For this problem, it's 3/2, 1, 2 pi, 5 pi over 6 to the left, and y equals 1. That y equals 1 coming from that 1, that phase shift coming from the addition here. Frequency is a coefficient, amplitude is a coefficient. Okay. Once I have those values, then I'm going to plot my, scale out my axis. Since I'm shifting 5 pi over 6 to the left, I'm going to leave myself some negative space when I go to draw my axes in because of that shift. And then I need 5 pi over 6, and I need to graph 2 pi. So 2 pi to help me figure out these values, I'm going to write in terms of 6. So 2 pi would be 12 pi over 6. So maybe I'll make each half box a sixth. So I'd have to go back 1, 2, 3, 4, 5, negative 5 pi over 6. And I make each half box so that I have enough space to get through my graph. So now if I need to go 12 over, and each half box is a pi over 6, I could count off each half, so that'd be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. If I'm moving 12 over from negative 5, that should put me at 7 pi over 6. I need to get one more period, so I'm going to count off 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So that should put me at 19 pi over 6. So now I have my graphs. I'm going to divide this period up into 4 equal parts. So since there are 12 in between, I'm going to count up 1, 2, 3, 4, 5, 6 would be right here. And I'll count up 1, 2, 3, 1, 2, 3. So there's I'm going to use larger hash marks to identify that breakup. So I'm going to take half and then each half. That gives me the sense of where my period will be. The midline is at 1. And since the amplitude's 3 halves, I'm going to try to give myself some half space. So I'm actually going to go up 1, and 2. I'll come down, negative 1, negative 2. So there's my graph. So the midline is at 1. So I'm going to make a little dotted line at 1 so I know where the middle of my graph will be. I'm also going to do a little dotted line at 5, 6. So I know where 5, 6 is. Sorry, it's a little tight. I'm just trying to make sure everything fits on the camera. The next, I'm going to figure out what's happening here. Now this is a negative cosine graph. So cosine, again, follows this pattern. So negative cosine should be the vertical reflection of this. So instead of up here, it'd be down here. And it's the same pattern, just reflected vertically. That'd be negative cosine. Is the blue graph. So I'm going to use those key points on that negative cosine graph to help me plot this along. So I'm going to start at my starting intercept, which is here. And since the cosine graph normally starts at its max, the negative cosine graph will start at its min. So the min should be 1 amplitude below that midline. So I'm going to have to go down 1 and a half. Put me right there. The next key point, I should be at the middle, corresponds to here. My next key point, I should go up to a maximum. So my next key point is right here. And if I scale up, that's 1. So I need to go up 1 and a half. So I should be right there. Then my next key point is back to the middle and then back down to the minimum again at my next key point. And that gives me 1 cycle of my cosine graph. And I need to repeat that. So from here, my next key point moves up. My next key point moves up. My next key point comes back down. And my last key point is here. Gives me a second cycle of that cosine graph. Now based off my scale, I made it a little tight. I probably could have done every box as a 1/6 of pi so that this is spread out a little bit more. I was just worried about the camera space, but that's basically how you can go through scaling each of your values.